students, welcome back to the advanced group learning. So today I'll cover the rest part of the trigonometric section, which is part 2 of trigonometry section. Okay, so in the last section I discussed about the trigonometric ratios of sine theta, cos theta and tan theta for 60 degree and 30 degree. Today I'll teach the angles 45 degree and 90 degree. So let us draw a right angle triangle, that is this. Let us name this A, B, C. This is 90 degree and this is theta. First of all, we'll cover this section of 45 degree. So this is perpendicular, this is base and this is hypotenuse. Perpendicular plus base square, perpendicular square plus base square is equals to h square. This is what Pythagoras theorem says. And if this theta is 45 degree, this is 45 degree, this is 90 degree, then obviously this angle would be automatically of 45 degree. Okay, this angle will be of 45 degree. Now angle opposite to equal sides are equal. So if angles are equal, then obviously sides opposite to them will be equal. So if 45, this is 45 degree and this is 45 degree. So if I take base as 1, then obviously perpendicular will be 1. This is 1, then this is 1. Okay. So by Pythagoras theorem, hypotenuse square will be 1 square plus 1 square. So hypotenuse square will be 2. So hypotenuse will be root 2. Okay. So this is root 2. Clear? Therefore, we know that sine theta is equals to P by H. Cos theta is equals to B by H. And tan theta is equals to P by B. Okay. So sine theta, here the perpendicular is 1 and hypotenuse is root 2. Clear? Here the perpendicular is 1 and hypotenuse, the base is 1 and hypotenuse is root 2. So cos theta is also 1 by root 2. And what about this? Perpendicular is 1, base is 1. So this is 1. So I hope this is clear to all of you. Why sine 45 degree is 1 by root 2, cos 45 degree is 1 by root 2 and tan 45 degree is 1. Clear? If now let me prove for 90 degree. Let me prove for 90 degree. So this is your right angle triangle. Clear? And this is your theta, perpendicular, base and hypotenuse. Okay. If I start moving from this theta, suppose if a person is standing over here, okay, then obviously for the person standing over here, this angle would be theta. Okay. What if this person starts walking? What if this person starts walking? So obviously at one point, this person at one time, this person will reach this point. So here, suppose he comes somewhere here. Okay. Suppose he comes over here. At one time he will be here. At another time he will be here. And suppose a time came when the person finally comes here. Okay. So let me take this point as D. So what you observe? You observe as when person walks. When person walks. What you observe here, theta is increasing. Theta is increasing now. This angle would be greater. This is like this over here. At this will be. At this will be. At this will be like this. So theta is increasing. Okay. Theta is increasing. What about the base? Base is decreasing. What about the hypotenuse? This hypotenuse is also decreasing. At one time it's like this, then this, then this, then this. So this hypotenuse is also decreasing. Okay, theta is increasing, hypotenuse is decreasing, base is decreasing. What is constant? Perpendicular, no change. Okay. So now if the person is finally over here, this position, finally over here, this position, so then theta will be similar, or the value of theta will be very close to 90 degree. Okay, so I'll take theta as 90 degree. So my this angle will become very close to 90 degree, and the hypotenuse will become perpendicular. Clear? This theta will come to 90 degree, very close to 90 degree, and therefore hypotenuse will become perpendicular. Okay, so what I got here? I get what here? Sine 90 degree is equals to perpendicular upon my hypotenuse. That is perpendicular upon my hypotenuse, and hypotenuse has become perpendicular. So what I'll get? 1 by 1. So sine 90 is equals to 1. I hope this is clear to all of you. For 9th and 10th standard, you don't need to prove how these ratios come. But for your basic knowledge and for your intelligence, so that if someone asks you why it's so, you must be able to answer that. Okay? Now, I have taught you the sine theta, tan theta, and cos theta for angles 30 degree, 60 degree, 45 degree, and 90 degree. Okay. So this was the rest trigonometric section. For 9th and 10th students, you don't need to learn more things about these trigonometric ratios. Now I'll teach you why the sine squared theta plus cos squared theta is 1. Everyone says no, why sine squared theta plus cos squared theta is 1. So this proof is very simple. Consider the right angle triangle. Consider the right angle triangle, perpendicular, base, hypotenuse. Sine theta is what? Sine theta is perpendicular upon my hypotenuse. Cos theta is what? Base upon my hypotenuse. Okay. Squaring both the sides. Sine square theta becomes perpendicular upon my hypotenuse square, and cos square theta becomes base square upon my hypotenuse square. Clear? Base square upon my hypotenuse square. So obviously when I'm going to add these two equations, 1 and 2, when I'm going to add these two equations, we have sine square theta plus cos square theta is nothing but perpendicular square upon h square plus base square upon hypotenuse square. Clear? So sine square theta plus cos square theta is, now here is also h square, here is also h square. So can I write perpendicular square plus base square upon h square? Now see, from Pythagoras theorem we have perpendicular square plus base square equals to hypotenuse square. Okay, so this is nothing but h square by h square. So I'll get the result as 1. So sine square theta plus cos square theta is 1. Okay. So this was the part 2 of trigonometric section, understanding the trigonometric ratios. If you guys don't have yet watched the section 1 part, then do watch that so that you guys can understand this part easily. So thank you.